All right. Come back wide.
Pulling wide.
Watch it open up. Well, turns out they're chicken eaters, not filter eaters. That previous comment.
Now, if we see another one, it would be great if it could be like up near those coral mounds we're trying to get to. We could do everything.
Comm says back to Alice.
I'm going to run into this.
Oh, there's a coral down there. Something.
Sediment core, and then there are large drills over.
There's some really big,
Yeah.
swelly waves of sand here.
Rollers.
It's interesting how the sand ripples change. Like just now they were smaller, more chaotic crisscrossing, and now they're in these really big lines with crests and troughs.
Oh. This one. Oh, I see it.
Meter right! Sorry. I'm so sorry. I'm so excited.
This is a fantastic dive.
Oh my god!
Get the sand out.
Yeah, I guess we just never go shallow, do we? Wow.
That is stunning.
Amazing.
Coming back towards you, you might want to come up on the...
Oh, it's gorgeous.
Oh, it looks so peaceful.
It may be peaceful, but my adrenaline, I think, just like spiked very sharply in the most positive way.
Rachel, if you can hear this, would love a hand.
It's about as far as we're going to chase it. Sorry, downlights, come back on. It's completely washed out. I'm going to turn it off. Right. Turning around.
While we're off the bottom, Shoreside is having some comms problems, but they were hoping to do a quick spin with the NORBIT if sometime around 300 meters, so whenever is a good time with the ship move.
Like come off the bottom and do a spin with the NORBIT, or like stay on bottom and do a spin?
Spin from around 10 meters.
Okay.
Ship is stopped right now, so it'd probably be a good time to do that.
Is that Manta first as well for Nautilus?
First manta ray, was it? I don't know.
Not sure.
I don't know.
Okay. You can come up, Rye.
And Eric,
I'm
is
gonna come
that
up
the
to 10
case?
meters.
Was it 10 meters that you were looking for off? I wasn't around for the last spin.
Yeah, it seemed like a 10-meter altitude gave us a nice coverage resolution trade space for sampling the
Awesome.
seabed.
Alrighty.
And we were interested in getting more associated with this.
Alright, gonna turn downlights back on here. Alright, we are at a...
What's our altitude right now?
Altitude is 10 meters.
Okay. Seems like the water visibility is a little bit better. If you can lights a little bit, maybe during the perhaps see a little better of the geomorphology from above.
Way too fast.
Lynette and friend Rose, sorry, I was looking away for a little bit there, but are we tracking spin percentage?
Spin percentage.
Does anyone have an eye on if it's a full rotation or a, yeah, how far we've gone so far?
I had no wraps when I started spinning. I should have a full wrap when I come all the way around.
Looking for full wrap, okay. Sweet.
Full wrap in the tether.
Perfect.
0.4 wraps right now.
And Eric, this is at least Hercules is at exactly 300 meters for this.
Hey all, we're having problems connecting from the ship to the V-Link server right now. Not sure what exactly is going on. I'll talk to Rachel and see what's happening.
Sounds good. %80 done. Looks like one full tether wrap.
Yep.
Is Pat Welch in the back row?
What was that?
Pat Welch is
Dr.
here, yeah.
Okay, a little dead area. A little larger mixed spiral this smaller. Yeah.
Okay.
All right, Patch, that's one. Pat, that is one full rotation. That good? All right, I think we're good to go.
Okay.
And you wanted a sample from right here too. Okay, so then a quick, we've been using the core tubes to scoop up sediment into the starboard bio boxes.
Just gonna take out this wrap quick. Okay.
Okay, V-Link is back up and running. Our scientists ashore should be connected again.
All right, awesome. We were just gonna take a quick core tube scoop sand sample and then move on.
What? Huh? Oh, I thought you said something. Okay. Core tube scoop. Yep.
We have a question from online about NORBIT and how to interpret what we're seeing on screen right now. What does the red mean and what does the yellow mean?
Can you hear us?
The yellow is the backscatter.
I can hear you, short team.
And the red is
Yeah,
the
many
contours.
times multi-beam sonar uses a form of echolocation, but instead of having a single beam, it sends out a swath of beams, sometimes up to over 500 beams across a sector. And you can envision that there's like we refer to it as a push broom sensor. So it's a scanning the seabed and then the movement of the ROV. That translation allows us to fill in the data in both coordinate frames of the X and the Y. And it's measuring altitude along this swath. Both the backscatter, so how much hard of a reflector of the seabed is, as well as the altitude is measured on each of these beams. So we can display the data both in terms of maps of backscatter, looking at whether it's a hard reflector or soft reflector, or we can
It could be
display
fine.
it
Oh,
as
look,
a
there's
visual
another
elevation.
shark.
Thanks, Eric.
Different types. The acoustic backscatter tells us something about the type of seabed that we're beneath the vehicle.
That's a
A hard
starboard.
return often might
starboard
be
rail
rock
cam,
or sand, and then if it is a weak return, it might be more of a softer material like mud.
Quick handoff of video.
Go up front. Yeah.
Dave's back in video.
Let me just switch it back.
What? Oh, that's the quote. I was like, what's coming? It's another red one.
There's that shark. I don't think you could get any more.
No, that was perfect. And we have one in B and C, so either A or D can get dumped into.
Are we still doing NORBIT surveys?
It's on, but not. We're not actively,
Yeah, not a dedicated survey.
intentionally.
Okay, great, thank you.
All right. Back to sample. And when you're ready. Okay, open in the box. Oh, oh. Boop.
A or D is open, right?
A
Back
or
row?
D, yeah.
Oh yeah, I can turn on the light for you. I'll make it easier.
A or D? Mark that sample.
Could I make a request?
Yep, just dumping it.
Go ahead, Sophia.
Could Derek and Jacob introduce themselves and say a little bit about their background?
Let's hear it, folks.
Sure. My name is Jacob Springman. I'm a autonomous vehicle engineer with Scripps Institution of Oceanography, and I'm out here to run a vehicle called the WAM-V, made by Ocean Power Technologies.
Okay.
And we're going to use it to survey some currents and temperature and some weather information in German Channel, which is where we're diving right now.
And I'm Derek Ung. I'm also an engineer with the same lab, same group with Jacob. And I principally run wave gliders. We're about to try and launch 2 of them after our ROV dives, keeping at least one out for another 3 or 4 month stint.
Freeze fail.
And
Freeze fail.
also on the side, I'm going to be assisting Jacob with the deployment of the WAM-V.
Yeah.
Could you tell us a little bit more about what a WAM-V is?
So, WAM-V, W-A-M-V, stands for Wave Adaptive Modular Vehicle.
This is the
And
armpit.
what it
Armpit
basically is a couple of inflatable pontoons that are mounted on with a payload tray above them that are mounted on shocks. And what that allows the vehicle to do is to stay a little bit more stable in heavy wave environments. So having a more stable platform to measure, to use instruments off of, provides you with higher quality data and allows you to do a little bit more than with say a traditional boat.
Doesn't help that it's wobbly. Doesn't help that it's wobbly.
The current watch has changed a little bit since we last did introductions, so thank y'all for starting us out. If we can go around again, because we have a bunch of new viewers since my last ridiculous question. My name is Alice. I am the Science Communication Fellow. And the last question that I asked that I didn't answer was, where would you like to dive the most, whether by sub, ROV, scuba, any of the above.
There you go.
And
Nice.
I've been thinking about this since I asked it, and I actually would love to see underneath the ice caps in the Arctic what sorts of fun critters are living there. I don't know what kind of diving you'd need to do in order to get there, but I would love to see it.
Yeah.
Woo.
Scoop core.
Yeah, I know. I don't know what to enter for that one either. This is like the Slurp smear.
Is that a crab?
Yeah,
All
it is a
right.
crab.
Crab.
Ready to get going?
Yeah.
Cool.
Front row, can we do some introductions, starting with Amanda? Except she's navigating right now. Sorry.
Stand by.
Rye, you want to go? You're just introducing yourself.
Who are
Name,
you?
place, who are you? Where, if you could dive anywhere, where would it be?
If I could what?
Dive anywhere.
Okay. Name, Rye, like the bread. Place? Is that what you were saying?
Yeah, like where you're from.
Oh, I'm from Vancouver Island. I'm sitting in the Atalanta seat. And I do not have my diving ticket yet. I'm going to get it this year. And then I will probably dive around Victoria.
What about ROV dive?
Oh. I don't know. Here is pretty cool. I've seen a Nautilus and a Ray, so. Alright, I'm gonna bring my heading around to.
Okay.
I'll go this way.
And my name's Jake Bonney. I am flying Hercules currently. I'm from Rhode Island, and I would like to dive, ROV dive, in the Solomon Islands next year, Guadalcanal.
You
That's
put
a
your
good
wish
one.
list for me.
Yeah. But I don't think it's going to work with my schedule, so we'll see.
Hey everybody, I'm Lynette. I'm one of the navigators. I'm from Wisconsin, and I picked the Great Lakes for my dive site.
That's a good idea.
Fresh water.
This is Pat Welch from Oregon State. I'm here as one of the research scientists. If I had to dive anywhere in the world, it would probably be underneath the Antarctic ice flows. Looking at ice from beneath is such an insanely beautiful thing.
I can show you some of my pictures, Pat. I have a bunch on my phone from it. Huh? Yeah, sure, to whoever wants to see them.
This dive, we are exploring the German Channel around Palau. Right now, we're at a depth of about 300 meters. And we're really happy to have all of the viewers with us. I see folks coming from the States, Mexico, the Philippines, Oman, the Netherlands, Germany, Guam, Australia. It's so nice to have you all with us. We have an answer from a viewer here about where, if they could dive anywhere, where would it be? And I love this one. Their answer is that they would dive Europa, which I think is a very, very good answer. Europa being a moon of Jupiter. We have another answer from a viewer saying that their ideal dive would be the ring of extreme depths that encircle the Pacific Ocean. Here's a question for the more experienced divers in this room. Has anyone ever dived the trench on the eastern side of New Zealand?
It's a very specific question.
It is an extremely specific question, and I don't know the answer to it.
Is that with ROV or sub or human?
I think any of the above would apply. So it sounds like no one in this room has done it, but there could be others.
I'm looking it up.
Thank you.
Yep. Yep. And that counter just is based off of our heading. So when we go in the water, we zero it. So based off of where, if the heading comes around, that adds a rep. Like if we come around 360 degrees, that'll be 1 rep. But it depends on the headings of the 2 vehicles. So.
Okay, so the trench question, I was assuming, well, I suspect what they're referring to is the Kermadec Trench, which is on the northeastern side of New Zealand. I don't think we have anyone on the ship right now who has been down there with ROVs, but it's definitely a well documented and frequented spot by like submarine volcanologists and other geomorphology folks who are interested in how that area of the world came to be. I think it's a subduction system. And it's also one of the Earth's deepest oceanic trenches. So
Cool.
yeah. But we definitely have had people on Nautilus who have been there with ROV, but I don't know, maybe Robert Waters or
Yeah.
yeah.
If I had to
one of
guess
the
anyone, it
pilots.
would be
Yeah.
him.
Yeah. I would love to go there too. I'll add that to my list. Next year may find Nautilus at the Marianas Trench. TBD. But as Nautilus continues west in the Pacific, that is, of course, one of the major features in the ocean west of...
We're changing out video again.
Where we are?
Y'all should have seen my face when Samantha said that.
But that is an announcement for another time.
Of course. Yeah, no, nothing settled.
Yeah, stay tuned for 2025 as things are...
It looks like there's something in that hole.
Yeah, Jacob came on just in time for all the interesting stuff. Looks like some corals living in those crevices.
This is a great rock.
Have we already zoomed on one of those stick-like possible corals sticking off of the rock there?
Stick. I don't know. Good question.
A quick zoom might be nice if we're
Just a quick zoom.
for it. Snap zoom.
You can push in there, Jacob.
Yep, going in.
Oh, maybe tube worm?
That's it, full zoom.
That looks more tube wormy. I'll grab
Alright.
there. Thank
Yeah,
you.
I see like the
Pick up and
little
move.
bristles coming out of the front.
Yeah.
Maybe some sort of fan worm.
Oh,
Oh.
there's another one.
Can zoom
This is
for
a
a second.
Paris
Yeah, push it in real quick.
Armored sea robin.
Sea rabbit?
Sea robin.
Oh,
Parasitidae, I
sea
believe.
robin.
All right. Come on.
You got it.
I gotta catch up. Couple of them. Another one there.
ROV pilots, is this a good time to ask a question from online?
Sure.
What's the limiting factor that determines how long dives can be?
There's no limit.
No limit. No limit.
Theoretically, but as long as the vehicles are healthy and we have, we've explored. It's really the area. Like, if we've explored enough of an area, there's no reason to stay down there. We want to move to another site. We want to classify as much as we can. So there's a good balance between kind of where you're going to explore, how long you're going to stay down somewhere. That's usually how we operate. We go down for somewhere between 12 to 24 hours, something like that. Explore an area, pick up, move the ship to another spot, and then deploy the ROVs again. But we've also done ROV dives where we're doing maintenance work on cabled observatories, where we're down for like 70 plus hours. And we could stay down longer, but there's just, there's no need to.
Wait, 70 plus?
Yeah.
Mm-hmm. I think one of our longest dives was 90 hours. That might have been Argus only, though.
Yeah, and then there are lots of commercial systems that will just stay deployed for months at a time for doing maintenance work and consistent surveys and that sort of stuff.
Limiting factor is something breaking.
Yeah.
Okay.
Yeah.
Including our minds.
Yeah, so on Nautilus, we usually have a max, as Jake said, of like 70 hours is like usually the longest we do.
Okay.
But that's, as he said, that's more about expedition planning versus, the vehicles needing to come up. But
yeah,
every time you throw something in the water, something's probably going to eventually need maintenance. So
yeah,
it's just kind of built into the schedule.
Yeah, we also run out of sample room. That's also a limiting factor. We only have so much samples and so much weight that the vehicle can carry.
And that includes the very, very large heavy rock that we had talked about yesterday?
Yes.
Okay. Like if we collected that rock, there would be no weight for anything else?
Yes.
Okay.
No, we looked at a big boulder though, and we joked about sampling it. Yes.
Would you need both arms to pick it up? No, that was a serious question.
That one was a bit large.
I didn't see the boulder.
Yeah, generally it's frowned upon picking up rocks that can't fit on the vehicle. Every now and then it gets put on the porch and has one arm holding it, but that's not very much fun for the deck chief, who then has to deal with it when it's on deck, and you know the potential that it could be fall out. So.
Yeah, that's fair.
Yeah.
And also, where on the ship are we going to put it? Like.
Also correct.
Yeah.
Yeah. And, you know, in the bigger picture of things, we try to limit our impact on the environment, so we try to take as small samples as possible. So that's why you'll see our team like snipping a small piece of coral, or, you know, trying to leave the whole animal there. So we apply the same thing with anything we collect, including rocks.
Is that a hermit crab down there?
Want to push in there, Jake? I think it's one of those.
Yeah.
Carrier.
A little anemone there.
Yeah. Fuzzy claws.
Oh, so cute.
All right, come wide.
Coming wide.
Lozenges?
Can we do a quick zoom on some of those smaller little corals sticking on the bottom part of that outcropping?
These ones here, or different ones?
Yep, perfect.
Okay, you can push in there.
And then, oh yeah, interesting. These look like anthomastus on the right. And then whatever's below as well, please.
Okay. You can come out wide just a little bit there, Jake.
Yep. That good?
Yeah.
Yep, some just under the lasers. Or actually maybe that. Ooh, actually, ooh, choose a side.
So many
There's
choices.
a lot there.
And push in there.
Oh, it's a crinoid. It's all crinoids. Okay.
All crinoid.
Crinoids upon crinoids.
I've got a bit more zoom if you
Okay.
want.
And then to the right actually would be great too.
Yep.
Okay, we got a cup coral. Great.
Okay.
Thank you. Quick little survey.
Can we get a comms check to shoreside?
Loud and clear, shoreside.
You can come wide.
Okay, I'm happy to report that Pat Cullen is back.
Excellent. Welcome back, Pat.
I'm glad to be back. That's a really lovely solitary coral right there in the middle.
Just in time.
Yeah. Okay, we've seen Nautilus. We've seen manta rays. We've seen six-gill sharks. Now I have one last thing to look for.
Okay.
And I would describe it as an orange basketball. Fairly small, red or orange basketball. I won't tell you anything more till we actually see it. And if we don't see it, I'm not going to tell you anything anyway.
Okay.
So it'll be the size of a basketball.
A little bit small, softball or larger.
Okay.
Get to the size of a basketball.
Excellent. We will be on the lookout.
Basketballs.
Depth range, so.
Go ahead. What do you see?
No, I was talking about the board.
In addition to the manta rays and the six-gilled sharks, are there any other common cartilaginous fish around here that we would expect
this sort
to see?
of depth?
Yeah.
Well, it's hard to know deeper. I mean, there's plenty of different sharks.
Yeah.
We saw a tiger shark once at 400 feet, 120 meters. That's the deepest shark I've ever seen, other than a six-gill. But
I don't know. There's some deep water stingrays. We saw a torpedo ray species at 300 meters. But other than that, it's pretty wide open. Those kind of look like large blocks of reef material that have fallen down. We didn't really, for the listeners, talk much about the whole area where we're talking about what we call German Channel. And really, German Channel is actually a misnomer. It's not what we should really be calling this, because German Channel is a inshore, it's near here, but it's up at the very shallows. It's a man-made dredged channel that the Germans dredged back at the start of the 1900s to ferry barges carrying phosphate, which was mined in Peleliu and in Angar, into the lagoonal area here in the main part of Palau to load on the ocean-going ships. So there was no easy way to get from open ocean areas. They had to bring this stuff up from Angar, or on the west side of Peleliu, which is open ocean, into the lagoon. There was no short route. And so at the head of this inlet that we're working up, it shoals up to literally it's just shallow reef. They dredged about a 1 kilometer long channel with steam shovels. I mean, how they did it in the old days. And that is the actual German Channel. So because of the manta rays, it's an extremely popular dive site. Everybody just calls it German Channel. That is not really the correct name. The Palauan name is pretty much unpronounceable to us foreigners. It's also known as Barnum Inlet. If you go and look at a navigational chart from World War II onward, it'll be labeled as Barnum Inlet. And it is an inlet. It starts out about 3 kilometers wide. In other words, you've got shallow reef walls that are 3 kilometers apart, with a bottom below that at about 300 meters, and everything narrows. The sides of the inlet narrow as it goes up towards the northeastern head where the manta rays are, and then the bottom also narrows. It gets shallower. So everything kind of converges on that head, and it's really kind of hard to see. I wish we had a map we could show you, but I like to think of this area. I call it an internal lens focusing device, because what it does is, if you get an internal wave of broad dimensions, it's horizontal, say 3 kilometers down at the mouth, well, that's going to be compressed, squeezed into something less than a few hundred meters up at the very shallow. So maybe that's not a very apt analogy, but I always like to call it the internal wave lens. So what we're seeing now, we're getting into, obviously a little bit rougher terrain. We're not seeing the sediment bottom, but still basically the same slope, 8 degrees, that we, determined from the bathymetric mapping. But in essence, it's being squeezed on the sides. It's getting narrower and narrower, and then shallower in depth. Again, remember our breaking wave analogy on the beach. You have air and water, but in this case, we have low-density water and high-density water. And we're looking at the beach right here. The high-density water is moved in. It develops a huge wave, and then that wave breaks when the bottom gets shoal enough, just like it does on a regular beach. That's a reasonable explanation, Sophia. You're the physical oceanographer.
I love your explanation.
Yeah,
Mine are often too technical, is what I'm told.
But it could be incorrect, too. We want to be untechnical, but also correct.
Yeah, so we refer to the internal tide as basically density interfacial waves at tidal frequencies. So once or twice a day, a diurnal tide is once a day, semi-diurnal twice. And they're just very similar to surface waves, but they are waves that act on density surfaces. So the fact that the ocean is stratified in temperature and salinity gives us the ability to support waves And that's what we refer to as an internal tide.
It's pretty depauperate down here. You know, when we see areas like this that look like a lot of really nice hard bottom that things could grow on, and there's really very little there. You wonder, why is that? What's the reason? You know, is there a reason that we can understand? And you know, all around Palau, you know, the internal waves are not isolated to just this German Channel or German Barnum Inlet area. There are internal waves hitting all the reefs, all the slope around the entirety of Palau. We have some of the largest. Focus in on that fish. That's a good one. If we can see it, I think it's a good one. Anyway, you have steep slopes all around Palau. The slopes vary. You know, this is a relatively gentle slope. That's not what I thought it was, but it's something very interesting. And I'm not going to be able to see. It could be a young grouper. It's a young grouper, I do believe. There's one that has that pattern as an adult. I do not remember the name, but it's a deep water grouper. It occurs a couple of 100 meters deep, and this is quite likely a juvenile. Oh, the fish people watching, please let us know, but I think it's a pretty good example of one of these deep water groupers. They never come into shallow water. You won't see this particular species diving. But if you go fishing out in a couple of 100 meters of water bottom fishing, they do catch them occasionally. Oh, that's a great image. Beautiful. But not what I thought it was. Anyway, getting back to, so you have the entire outer slope of Palau. And so internal waves transit massive distances in the ocean, thousands of miles or kilometers. Basically, you can think of them as two different types. There are ones that can be produced or generated at some remote island or someplace really far away from where you are, but it's like any waves in the ocean. They get generated, they build, and then they travel a certain direction, and eventually they may end up on the shore of some island. Well, the same thing can happen if you have internal waves produced in areas, say like the Philippines, which is about 1,000 kilometers west of Palau. Those internal waves can be generated by currents hitting islands or shores or large islands, reefs, whatever, and it produces this disturbance in the different layers of water, and that then is transmitted across long distances. And that's an internal wave, something like that, yeah. The other type are ones that can be generated locally. Again, it's just like, the example from the Philippines. Well, Palau is an island. It's a very steep topography. It's sitting right in the middle of some very strong oceanic currents. And so when those hit the shore of Palau, the slope, they may have this vertical structure of temperature and salinity, the density. They hit Palau, and that is disturbed. Again, it's the same old thing of, these internal waves like we think are breaking here at German Channel. Well, the wave breaks and then it goes back out to sea, right? And so the same thing happens along island slopes where the internal wave, an external internal wave comes in, gets reflected and goes out to sea, or the layering in the water can get disturbed, and that produces waves locally that then radiate out from Palau.
So one of the things that Pat has done for a really long time is to measure temperature at different depths. Maybe 20 years.
More than 20 years, since 1999. That's 24 years right now.
What kind of depth do you deploy these sensors at, Pat?
As deep as possible. I wish I had an ROV like this. We'd be putting them at 1,000 meters, but generally they're in the upper 100 meters. That's where most of the internal wave action is, if you want to talk about that in terms of action. Most of the variation you see will be occurring in a band from, say, 30 to maybe 100, 120 meters. So what we do is we take an instrument that you can program it to measure the temperature at some interval, let's say 1 minute or a half an hour or an hour or once a day. But usually we look for 30 minutes to 1 minute interval. So it's taking a measure, recording the temperature electronically every minute to 30 minutes. You leave that out for, say, a year, which is very common. So, once you have to go out, unfortunately, recover the instrument. We usually put a new one out at the same time so we get a continuous record. But you bring the instrument back in, you download it, and then you have a record and a picture of how the temperature has varied over the last year or whatever length the period is. And we've seen some incredible surprises. I don't know who exactly keeps statistics on these sorts of things, but because of these slopes like you're seeing here at the German Channel Inlet, where you have a nice, steady, relatively smooth bottom that's rising, not steeply, but fairly gentle. In this case, I could say 8-degree slope. You can see massive changes in the temperature at a given location very, very quickly. The best record we have here, it's not at this point, but it's down at Angler Island where the ROV was yesterday at the south end. I have a temperature logger there. It's at about 50 meters, and it's been there over 10 years. It records once a minute, so it gives us a really good picture of how dynamic the temperature is. Okay, so back during a strong El Nino, we won't go into that, but that instrument, the temperature at that point changed 11 degrees centigrade, pardon me, 11 degrees centigrade in 1 minute at that depth. That's 20 degrees Fahrenheit. And over 3 minutes, it changed 14 degrees centigrade, which is about 25 degrees Fahrenheit in 1 minute. If you were diving down there, and also because it's from a breaking wave, you would probably be swept away by the internal wave. But if you could hang on, you'd go from relatively comfortable to freezing in 1 minute. It's like an Arctic blast in the ocean. It's quite incredible. We've seen lesser changes of 5 or 10 degrees in just a few minutes, many, many times in Palau.
Just
so
an
we like to
update
think
from
of the
Nav. We're good on time, so if we want to do any more zoom in, zoom out, we've got some extra time for that.
Okay, great.
Got a little model.
I think that's another one.
I think that's number 3.
Number 3.
All right, I knew there'd be another one. So we are at
push in there.
Absolutely.
44 meters. Again, look, this was just sitting out on the open bottom.
I can't believe we've seen 3.
Just gorgeous. Perfect timing.
Yeah.
Oh.
We're not done yet.
Yeah, exactly.
Wow.
We might see more.
Yeah. Beautiful.
Fantastic.
I want to see one with a tag or a number written on it.
Okay.
But then we'll know where he came
let's
from.
not get greedy.
I know. Then we'd have a data point.
Okay.
How do we know this isn't the same Nautilus as someone else?
This one looks smaller.
Wow, it's
Well, you
perfectly
look
posed.
quiet.
I love its little pinhole camera eyes.
Nautilus. Hey, Nautilus guys, I have to tell you, we're playing a joke on you. We've got a half a dozen, ceramic Nautilus, and we put them out in this area.
Hey, you know what? It's working.
That would have been fun to do, we could get a giant Nautilus, dump it down there, have you find it.
Could have been a whole setup.
Anyway, no, this is the real deal.
We've had at the entrance of CRF, there's 2 flower pots. What kind of flower pots are those?
They're shaped like Nautilus shells. Yeah, Nautilus shells are ubiquitous and, marine art.
I'm really excited because we're going to be on the physics in
Ooh.
German. Oh.
Forget the Nautilus. There's a coral to the right of it. Get that Nautilus out of there.
Forget the physics. Let's get the coral.
Yeah. No, we don't want to collect it.
Okay, we just want to look at it?
Yeah, you want to zoom in on it? We got time, right? Just
The coral?
Yep.
zoom in on the coral, and then we can go
we're already
back
at
to the
full zoom,
Nautilus.
Jake.
Okay, I'd have to hop a bit forward if you come wide.
Yep, gotcha.
He just gave us an okay on zooming.
Okay.
Is that okay?
Yeah. You gotta tilt down and hop
That's
forward.
interesting because we're out on an open bottom without very much, and here's this. Oh, there's some more corals. here's a coral that's growing attached to some type of hard bottom, but it's just out here in the middle of nowhere.
Is there a big crab just above the Nautilus?
I think so.
One of the hermit crabs? The carrier crabs?
I don't know.
ROV, could we get the lasers off for some photos?
Yep, you can push back in there.
Great,
Gotcha,
thank
going
you.
in.
Oh, there, right. Yeah.
Is Samantha
Okay.
still on watch?
Yep, I'm in the science logger seat right now.
Translucent.
Could we also ROV back up a little bit if possible?
Back up?
Yeah, we're going to try to get it framed in the cinema cam
Okay.
for some beauty shots.
Roger.
Short team was wondering if the dive clock counter pauses during all Nautilus video.
Are you looking at the cinema or the Thurber cam, the section cam?
This is the cinema cam.
Okay.
Can Nautilus see where they're going when they're using their water jets?
Do they have a navigator, you mean? And a bridge?
Come wide a bit, Jake.
Yep,
I'm
one
gonna see if I
wide.
can
Just say wide.
frame up the...
So Nautilus have really, well, somewhat simple eyes. I mentioned it earlier. They have pinhole eyes, which function almost exactly the same as pinhole cameras. So even if those were positioned in a way where they were on the back of the shell, the resolution is still very, very low. What it sees is going to be relatively blurry.
That's just about center of the frame.
Up above the Nautilus, there's a hermit crab. There, that's him, right?
No, I think two.
Is up. You need to pan up, I think. This is a hermit crab. It doesn't have a shell, but it has.
You can push in there, Jake. If you want.
Going in. Looks like we got two crabs.
Yeah, there's two of them. Yeah.
We've seen it several times.
Possibly
Which
three.
we thought. There it is.
There
right.
it is.
You
Can you zoom in on him?
Yeah, 3 o'clock from the Nautilus, 2 o'clock.
And if we could stay
Yeah,
here...
okay.
Full zoom.
There's another one. So we've seen these a few times, but we're really curious what in the world they're carrying. It looks like we were thinking sea anemone before. If we could go to try and catch one of those, maybe slurp them up, that would be really interesting. I don't know how big they are. They might go up the tube. I mean, they're not going to be easy to catch, but it's really, really interesting.
The translucent back.
Yeah, it's got polyps. I mean, it could be anemone.
Before we sample, could we just sit here for the Nautilus beauty shots? Just for another minute or two? Great.
Just don't let those crabs get away.
Okay.
It'll make you go find them.
Yeah, and the beauty shots actually are with the cinema cam, so if you still want to zoom around with the Herc Zeus cam, that's no problem.
Look, there's some hermit crabs next to this one, next to the Nautilus.
Yeah.
It's a popular spot.
Everyone wants to be friends with the Nautilus.
I mean, I can see why.
So is the Nautilus hanging on in the sediment with its, do they call them tentacles or?
Yeah, they're tentacles.
And is it hanging on to the sediment or is it just perched on the sediment?
I don't think they're hanging on. They use those to feed. I guess it's sitting there because it's slightly negatively going. You're seeing them rocking back and forth a lot of times. That one's rocking a little bit.
From the ROV pilot's perspective, do you have a sense that this one's also aligned with the flow? The previous one resting was pointed into the current.
Yeah, it looks like the current's coming right to left across the screen. So, and that's how it felt when flying the vehicle as well. So,
How many tentacles do the Nautilus have?
I'm not going to commit to an answer.
I've usually heard...
Yeah, I'm not going to answer because I'll probably give you the wrong answer. You'll have to look that one up, I'm afraid.
All right, on it.
I've heard several dozen.
Okay.
A species that we had on exhibit at Monterey Bay Aquarium a few years ago had 90 tentacles.
90?
Yeah.
Okay.
But it just depends on the species. I don't know what this species has.
Yeah.
So we are done with the beauty shots. Thank you. Shoreside Science, do we want to collect one of those furry carrier crabs?
Yeah,
Absolutely.
we're
Okay.
excited.
Great. We have excited scientists on shore. So
Okay.
ROV, let's
Come wide.
Zoom
pick
in.
one.
Google says more than 90 tentacles.
Great.
Wow.
Thank you, Google.
We think this is gonna fit in the slurp?
They're right
or-
there. A little bit,
Looks
like
like top
2
left.
o'clock from the Nautilus.
Oh, got cleared out some stuff from the flush there. Were you guys trying to suction coral earlier? By any chance?
Oh, I see it.
Can someone tell me if flush jar 1 is open?
I can tell you that. Yes. All your slurps are open.
Perfect. And I don't know if you want to put in your notes that when I flushed into the flush jar, we got some coral in there.
Great. Any color in particular?
We've got some white coral. I can actually show you. Samantha, can you see the flush jar camera right in front of Nav there?
Yeah. Okay.
Yeah.
Oh, I see. White and brown, it looks like.
Yeah.
Okay. That might have been from yesterday.
Yeah.
I don't know if, I don't think there's been any slurps today.
Yeah, might fit.
Go ahead.
Bottom, yeah, they've got it.
Yeah.
Okay.
I think that'll fit. Go full means on the section.
Right.
Can you just tilt down a little bit?
Tilting down.
And if we could just take a zoom on the one that we're going to collect for photos.
Yep, you can push in there. Actually, wait, let me grab this.
Okay, I got a section.
You got it?
Yeah.
All right, you can push in there.
All right, zoom in.
Zoom, zoom.
We happy with that zoom? We want more or less?
More if you can.
Yep, I got it.
Oh, great shot. It's even turning around for us. And lasers,
Ouchie.
please.
Got to come wide for the lasers.
Going wide.
Okay. There we are. Okay, looks like under 10 centimeters, potentially. Thank you for crawling towards the lasers.
Just a little bit more. Perfect.
He understood the
Now come back towards us.
Circle back, ready
towards the
ready
slurp.
for pickup.
Come to the slurp. Yep. All right.
Alrighty, thank you.
How well
Okay.
You can
behaved.
come a bit wide.
Yeah, can you just pan over?
Well,
Yep,
man,
panning over.
specimen.
Doing
All right,
circles.
Get that slurp on.
Slurp's coming on.
Okay.
Oh.
Oh!
Okay, watch it come into the jar. There
Yep.
we go.
All right, section off. Section off.
Oh dear.
That was very well mannered. Okay.
Okay. Oh, and it's.
Oh, we've got a little, one of the little hermit crabs with the
Wearing a
different
shell?
shells. Yeah,
Yeah.
there's two in there
I love how the suction just goes.
with the pointy shell.
Redeploys itself.
Herc depth.
All right. Yeah, you're back on
Herc.
flush jar. Perfect.
Okay.
What were you pointing at? Oh.
That was a lot of things in the slurp tube, eh?
All right, you can
Little
come wide,
treasures.
Jake.
Going wide.
We'll maybe put the if there's a free jar at the end of the dive that isn't the flush jar, we'll maybe switch to that, so we don't lose those.
Okay, science on shore. Anything else here you want to take a look at?
Move onward.
Roger.
We have a question from online. Do animals ever try to interact with the laser dots from the ROV, like a cat trying to catch a laser pointer?
Well, that crab certainly was interesting. Did exactly what we were hoping for.
Sometimes I wonder if the fish kind of seem to be really attracted to that, like the shallower water fish.
Some of the fish are definitely attracted to the lights. I don't
Yeah.
know if I've seen the lasers specifically.
I think in relative to the lights that are coming from the same direction, which are very bright. Like if you were staring at the front of the vehicle with the lights and the lasers on, you probably would not really notice the lasers. So I'm not sure that they really see them, honestly.
Well, if all samples are that easy to collect, we can do a few more in the time that we have left.
It's also possible that fish this deep don't have the capacity to see green. Usually, the wavelengths of light that come through the water changes as you go deeper.
Yeah. Was that a question?
Did that just pop up?
Yeah.
Just an observation.
Don't update during the dive.
Reboot your computer now. Alright, I'm just doing gauges. Shout at me if you need anything beyond the basics.
Gauge away.
Thanks. Gotta get at least some data points in here.
Bob and Dan been filling it out?
Yep.
Sparsely? Copy and paste. Push in there, Jake.
Yep. Is this the same as the other one we saw a little bit ago?
I don't know.
Whoop. Whoop. Alright, he's shy.
Yeah, we go. Zoom in on that fish. It looks like the same grouper we saw deeper. So again, a very small.
Hiding. Two of them. Come on.
From what? Yeah, doing a quick handoff of video.
Dave's back in video.
Welcome back.
Thank you. Glad to be here. Guaranteed nothing will happen. Okay? I bring Jacob in. There's sharks and nautilus and rays and crabs and yeah. I come in here. What do I get? Rocks and sand.
Dave, have you seen any of the 3 Nautilus?
Yeah, I was watching them downstairs.
Okay. Well,
yeah.
Oh no, but not from here.
What is the? Oh, palms.
Palm. Birch. Coconuts.
Take a
Just
quick
telling
zoom.
you,
Urchins.
Jacob's a lucky, lucky man. And he's been sitting here mentally editing all the highlights in his head.
Those palm fronds?
Yeah, we didn't ask
Are the
Jacob if the
urchins?
nautiluses were a 5.
They were a 5.
It's interesting those sea urchins are on that dead palm frond. Maybe it's the lunch on the menu. That's kind of an interesting observation. Why don't you, zoom in and get some nice footage of that?
You can zoom in there.
That's interesting. But not too far. That's pretty good, really.
Dave, don't say we see nothing, Dave. You got the look he just gave me.
Pat, would you say that those are multiple species of coral on there, or just different color variations of the same kind?
They do another,
Yeah. So, actually kind of interesting. Look to the left of the urchin in the center, and there's sort of like serrated indentations in the palm frond. Maybe it looks like he might have been chomping on that, which would imply that he's directly eating the palm frond material.
So we've just crashed an urchin buffet.
Something like that, yeah.
Yeah.
But this is going to be a big buffet. This is going to last a long time, I guess.
All right, we can come on. Boat's still moving.
Yeah, we can keep moving onward.
We have some new viewers online from Finland, the Northern Mariana Islands, and from the UK. Welcome. What are those brown
like bottles again? Perhaps.
Yeah, there's a neck in one of them. At first I thought they might be egg cases, but too round.
Can't be because Dave's here.
Aha.
Yeah, can you zoom in on that dark sea anemone in the center of the view?
Backwards. They have a lag. Yeah. Back up, back up, back up. There it is. All right, push in there.
It certainly does contrast against the white bottom.
We have a viewer asking what the difference between corals and sea anemones are.
Well, they're both cnidarians, and they're pretty closely related.
Shrimp.
They are hexacorals, if I remember correctly, and they're in different groups. Sea anemones don't have a calcareous skeleton like a stony coral does, so the polyps are very similar in their construction, but other than that, you know, the calcification, the construction of the skeleton is probably the major difference. You know, straightforward, simple difference to distinguish them.
Okay, we happy? Happy there? Come on.
Yeah, that's great. Thank you. That's a nice contrasty oral disc there with the white pale area.
And no sign of an orange basketball yet.
Not yet.
We can always hope.
Jacob will have to come back up for a minute.
One viewer wants to know, if there's a website that keeps track of all the new species discovered by Nautilus?
Oh, yeah, there's Nautilus. Another Nautilus.
Number 4!
Oh my gosh. Would you look at that? I guess we better zoom.
Oh no, how terrible.
Okay, Dave, this one's for you.
Yeah. Push in there.
Great shot.
Yeah.
Oh, thank you for turning for us. It's perfect.
Okay, are we going to start a pool to estimate the total number of Nautilus seen on this dive? Everybody can pick it.
I'll bet 7.
Come on.
If you win, what do you win? And that's the dive with the Nautilus, with the ROV, the Hercules.
Oh, they're so cool.
You can push back in a bit.
Something about the way they move just seems like it's wrong. Like,
Well, it's like watching a dinosaur.
yeah.
Their body pattern
It's
or
like
their
redefining my understanding of
Yeah.
liquids. Like,
their morphology hasn't changed in thousands, millions of years.
I also love the slight rocking
Don't
to
be
it.
chasing
Like,
for much longer.
yeah, I'm way ahead of you.
Go until I feel a yank.
I have an interesting question from online. Do the patterns on the shells of these nautiluses, I haven't decided, would those be able to help us tell them apart, like our fingerprints?
It's my understanding they probably would, yes. Each one is distinctive to an individual, I hope, or I think. And I don't know if anybody's ever done that study. They might have. They've seen plenty of shells over the years, but yeah, it could be an individual recognition factor.
So I guess that means that there's a chance that this is one Nautilus that keeps following us.
Yeah, well, you could take all those still images you shot and put them one against another and check it out. That'd be kind of fun to do.
It's a project for someone at home.
They look like if you brought them into air, they would also hover there as well. Like, just,
I'm just imagining like nautiluses like right behind our head or around our shoulder, just like floating along with us like familiars.
yeah, like gravity doesn't mean anything.
Good job, Dave.
Congrats on the curse being broken.
Oh yeah. You're allowed to stay.
Alright, I got a tall feature in my sonar there. Yeah.
A little bit of mud on Atalanta.
Yeah, it's about time it's got its hands dirty. There we go.
Another Coke bottle
That's
for
another Coke
Dave.
bottle right
Yeah.
there.
Did that one yesterday
Can
come
we zoom in
up
on it?
intact?
You want to zoom in on the?
Yeah, I'd like to just take a look.
Yeah.
Earlier, Samantha mentioned that these Nautilus probably haven't changed their morphology
Push in there.
at all, as far as we know. And then someone asked, how far back do Nautilus fossils date? And just about 500 million years are the first fossil records of Nautilus that we are aware of.
Broken,
Wow.
unfortunately. Same vintage, 38 to 44.
It's got a lot of sand in it.
Yep.
Yeah.
But yeah, same vintage as the one we brought up yesterday.
It's like
I did a full ID on it for Leland.
It's like a push core sample.
Yeah. Automatic push core. Scoop core. Look at these.
Thanks for that fact check, Alice.
Of course.
Cool. I guess I should have said hundreds of millions.
Yeah.
Wasn't expecting that. That's awesome. Oh, this is interesting. Sand ripples here.
Mm-hmm.
You okay?
All good?
Well, there's like
More Coke
a lot of
bottles.
them.
So that Coke bottle's different. That's a clear glass Coke bottle.
Well, and there was another one back in this
Yeah,
one.
there was. That one looks intact. No, neck's broken off of it. But that's a clear glass Coke bottle.
Huh.
In the World War II period, overseas or export bottles were made of clear glass instead of green.
Wow.
So we have a request from the onshore team for a collection of one of those Coke bottles if possible.
That's great. We actually collected one yesterday.
Back up the truck. Let's
Stop
get
the-
that clear glass one.
Stop the boat.
So on shore, are you looking for another Coke bottle to compare with the one we collected yesterday?
Yeah, of course. Yeah, we need two specimens.
Okay.
You know.
Rudder.
No, you know, because of the there's a lot of people like Eric who work on World War II vintage wreckage here in Palau. It'd be kind of fun to have a Coke bottle for a display, just to show what they were like back then.
Okay, we're
I'm
backing
sure
up.
it's not plastic, which is good.
We're going to try to find it.
Is that one right there?
It's right there.
Yeah.
Yeah, there was another one I saw to the yeah, that one there's beautiful.
This one's better shaped than the other one was.
Okay. This one? Right here? Yep.
Yep.
All right.
Well, there's lots of sand on the... How do they get so much sediment on the plates there?
Should we take a look at it
Yeah.
first?
Yeah.
Go over zoom.
Push in there.
'Cause I think
Yeah, we love the, you know, it's actually a biological sample because, you know, you get these small micro mollusks that get in there and get trapped and
yeah,
quite
looks
often
like
die. So the
looks like the
inside is
neck.
just as important as the bottle.
looks like the neck is broken.
Stand by for those grabs.
Just so back down and to the right, there was a second one that was pretty well buried, I think, very close by. If you want to back up a bit or back out.
Is it broken or just in this?
Don't know. Couldn't tell. Let's.
Do you want me to zoom in a bit, Dave? I'll just
Sure.
get the neck out of the
Poke it.
weeds here. You're thinking this part of it is broken, maybe?
Oh, no. Good call. That's intact.
Nice.
Yeah, that's in good shape.
Grip force 0.
Yeah, I'm gonna do 1 was the...
1 was what you did yesterday?
Yeah,
Nice.
and then just put the clippers on the back side of it here.
It is the strongest part.
Sorry?
That's the strongest part, the base of the bottle.
Yeah.
And we're gonna
Well,
do
and I just don't want the clippers on it.
starboard bio box for this, E or F?
If
Or A?
that's- I have it? Oh, I got a rock right in my... There we go.
Oh yeah,
All right.
totally.
Put the craft on the bubble.
Sounds good.
And I'm gonna go to the sample.
Sounds good.
Switch over the cameras. Turn on the lights. And put the box.
Yeah, here I am. I'm up.
Okay.
At least I think I'm up.
You said E or F?
Yeah, E, F, or A.
Okay. We can do A. That
Okay.
way you save the big ones
Perfect.
for like a rock or something.
Great.
We'll do. And unfortunately I'm going to have to kind of drop it if we don't want to pour the sediment out. Or I can do more.
I think drop would be okay.
Yeah, I can. I think it should be. Oh, freeze. There you go.
Nice.
And yeah, hopefully that.
Rye, we have a couple compliments from the chat on your manipulation skills.
Thanks. Okay, blue button.
Nav, can we get an update on distance to go in the next 2 hours of this dive? Distance remaining.
Another bottle. Another bottle. In the sediment.
Was it green or clear?
Clear.
Oh.
Interesting.
Distance to go is 305 meters.
It's strange that there would be different ones, like all together.
Would this be an okay time to do the NORBIT path?
You want to come up off bottom and do another NORBIT spin?
Yes,
Is that what
we'd
you're
like
saying?
to do that.
Okay. Want to push in there, Dave?
Whoa.
Whoa.
What is that?
Oh, that's a good, that's a Zeus.
Zeus.
Look at those dorsal fins.
One of those. Yeah, let's get some good beauty shots of him.
Oh, it's
Nice.
It's so flat. Jinx.
It's flat.
What is this?
Look at
looks
how
like
the
a
side,
mirror.
yeah, the side reflects the sand so well.
Narrow body.
Beautiful.
Beautiful view in lower right now.
Like he's bouncing off the bottom.
Oh. Blinded by the light.
Nice hairdo.
I'm gonna turn the lasers off. Go for it.
Nice hairdo. Amy's hair.
Gorgeous.
Does anyone know what this is?
It's a known species. The name escapes me at the moment. It's like Zeus or one of those. It's a particular group of fishes. Yyyy-mm-dd, I think, is the family. Don't quote me on that. Let me look it up.
It's so cool.
Nothing to eat on that fish.
There's some little like spikes on it too, on the side. Little mini ones.
Ooh.
Oh!
Yeah, we're having that as a Zeus Faber. Zeus is the genus, Faber is the species.
Nice.
It is known from Palau, so it's not a new geographic record, but it's a beautiful fish, that's for sure.
Zeus swam straight at the Zeus.
Can you repeat the species name?
Yeah, we're pretty sure it's Faber, F-A-B-E-R.
Great.
It's a pretty common deep water fish.
Okay, thanks.
Okay. Set up for a NORBIT. Come up to 10 meters.
Throw these targets in there. Whoops.
All right. Going to start the survey.